Hello, this is Dr. Hanaa Assil, and this is the second part of questions and answers on chemical bonding. So let's take a look at some of these questions. The first question here says, potassium combines with iodine to form potassium iodide. Which of the following describes the bonding in the three substances? Now, potassium alone as a metal has what kind of bonding? You should realize that metals have what we call metallic bond. Iodine is simple molecular structure, so inside it has covalent bonds in which two iodine atoms are sharing a pair of electrons. For potassium iodide, of course, this is a metal that loses electrons and a metal that gains electrons, and we have positive and negative ions in a giant three-dimensional crystal lattice. This is ionic bond. So that would be the answer. Ions with the same electronic configuration are said to be isoelectronic. Which of the following compounds is made up of isoelectronic ions? So, isoelectronic means they have the same number of electrons. So, which of these, the positive and negative ion, have the same number of electrons? So, let's take a look. Calcium oxide. Where is calcium and where is oxygen? You should remember, when a metal makes ions, it loses electrons and it gains, or it becomes, the noble configuration of the previous noble gas. So calcium loses 2 electrons, it becomes 18 like argon. Now non-metals gain electrons and become the same noble configuration as the next noble gas. So oxygen gains 2 electrons, it becomes like neon, 10. So these are not isoelectronic. Now calcium and bromine. Now calcium would lose 2 electrons and become like argon, 18, while bromine would gain 1 electron and become like krypton, 36. So they're not isoelectronic. Now sodium and oxygen. Sodium loses 1 electron and becomes 10 like neon. Oxygen gains 2 electrons and becomes 10 again like neon. So this is actually my answer. If we look at lithium and fluorine, lithium would lose 1 electron and become like helium. Fluorine would gain 1 electron and become like neon. So the ones that are isoelectronic are the sodium ion and the oxygen ion. The diagram below illustrates a metal or a model of the metallic bonding in rubidium. Write appropriate labels in the 2 empty boxes in order to... So this is a diagram of a metal. How do we label the diagram of a metal? Remember, the metal is made up of what? Delocalized electrons and regular rows of positive ions. The type of bonding in potassium is metallic. Draw a label diagram to illustrate metallic bonding in potassium. How do we draw metallic bonds? You should draw positive ions in rows, and they should be near to each other. They're actually closely packed. So they're regular rows of closely packed positive ions surrounded by a sea of delocalized electrons. So this is how you would draw it if you're required to draw the diagram of a metal. Complete the dot and cross diagram to show the bonding in nitrate ion. Now, how do we draw dot and cross of nitrate ions? First of all, he specifies a specific notation, so please follow it. Nitrogen electrons are crosses, oxygen electrons are dot. Now, nitrate ion is something that has 1 extra electron. It has a negative charge. It is nitrogen with 3 oxygens with a negative charge. That means there is 1 extra electron. This extra electron we denote by asterisks, and we put it on one of the oxygens. It doesn't really matter which one, but here he's specifying where the asterisk is, and that means that oxygen has that extra electron, so it will need only one from the nitrogen. So the one that has the asterisk, which is the extra electron added, will need only one electron from the nitrogen, so there is only one pair of electrons being shared between that oxygen and nitrogen. Now, the oxygen on the left, or somewhere, one of the other oxygens, would have, it has 6 electrons, it needs 2 more, so it's going to share 2 pairs of electrons with that central nitrogen. Now the nitrogen has already too many electrons, so it cannot share and take electrons again from the oxygen. So the oxygen on the right will have its 6 electrons on its own, and it will have a dative bond from the nitrogen in which both electrons that are being shared between the nitrogen and the oxygen on the right are coming from the nitrogen, so that is a dative bond. Conventional toilet cleaners contain bleaching agent. Chloric acid is one substance that is used as bleach. Draw a dot and cross diagram for HOCl. So we're going to draw HOCl. The O, of course, is in the middle, and that means the O will share one pair of electrons with the hydrogen and one pair of electrons with the chlorine. So this is normal covalent bonds with pairs of electrons being. Graphite has a structure containing layers of carbon atoms in hexagonal rings. So why is graphite a good conductor of electricity? Remember, this is a structure of graphite with layers of 6-sided rings in which each carbon is covalently bonded to 3 other carbons with weak attraction forces between the layers. Now, why does graphite conduct electricity? Remember, this is because one of the electrons in each carbon is delocalized, so they are mobile or free to move, and this allows graphite to conduct electricity. The dichromate ion has 2 chromium atoms sharing 1 oxygen to give 2 tetrahedral units. Each chromium atom uses 6 electrons in bonding and expands its outer shell to accommodate a total of 12 electrons. So actually we're being told that the chromium is an exception to the octet rule. So instead of having a total of 8 electrons around it, it will have a total of 12. And whereas to complete the dot and cross diagram for this ion, show outer shell electrons, and we're given a specific notation, so you have to follow that notation. X is for chromium, dots for oxygen. Use the symbol asterisk to represent the extra electrons. Remember, this is an ion with 2 negative charges. That means it has 2 extra electrons, which we're going to represent with the asterisk. And we need to put these asterisks on the oxygen. So I'm going to choose 2 of the oxygens, put asterisks on it, and that means that oxygen needs, you know that oxygen has 6 electrons in its outer shell, it needs 2. So it takes the oxygen where I put the asterisks will need to take only 1 or share 1 lone pair of electrons with the chromium. The other oxygens on the top and on the right and left, each oxygen needs 2 electrons from the chromium, so we're going to share 2 pairs of electrons with the chromium. Now, the oxygen in the middle needs 2 electrons. It's going to share 1 pair of electrons with each of the chromium ions. So this is the dot and cross for the dichromate ion. Please pay attention to the dot and cross of these kinds of ions. Again, complete the dot and cross diagram for the bromate ion. Show only outer shell electrons. In this ion, the bromine expands its outer shell again to accommodate 12. So the bromine will have a total of 12 electrons around it. X for the bromine electrons, dot for the oxygen electrons, the symbol asterisk for the extra electron, because again this bromate ion has a negative charge, and that means we're adding one more electron. We're already given that the asterisk is on the oxygen on the right, so that oxygen will need only one pair of electrons from the bromine, sharing one pair of electrons with the bromine. The other oxygens up and down, each of them needs 2 electrons, so they're going to share 2 pairs of electrons with the bromine. The bromine has a total of 7 electrons of its own, so it still has 2 more that are away from the bonding. A liquid which conducts electricity continues to conduct when it is cooled and solidifies. Which of the following could it be? So we're told that we have a liquid, and when it becomes solid, it still conducts electricity, and we should know that the only substances that conduct electricity as a solid are the metals, except for graphite, of course, but metals are the ones that conduct electricity as a solid. So which of these is a metal that's originally a liquid? Of course, that is mercury. In iodine pentoxide, each iodine atom is bonded to 3 oxygen atoms, and one of these oxygen atoms is bonded to both iodine atoms. Complete the dot and cross diagram for the molecule using dots for the oxygen, crosses for the iodine, and we are told that the iodine has 12 electrons, a total of 12 electrons around it. Again, each oxygen needs 2 electrons from the iodine, so we're going to share 2 pairs of electrons with the iodine. The oxygen in the middle will share 1 pair of electrons with each of the iodine. Remember, the iodine has a total of 7 electrons of its own. It has used 5 only for bonding, so it has 2 electrons somewhere away from the bonding. So this is the dot and cross for iodine pentoxide. Please sit down and practice drawing these and then check your answers. Most solids exist as lattice structures. Complete the table using a tick if the substance conducts electricity, or a cross if the substance does not conduct electricity. Again, if I have sodium, you should know that sodium is a metal. Would it conduct electricity as a solid? Yes. Would it conduct electricity as a liquid? Yes. Remember, metals conduct electricity both as solids and liquids. Now, sodium oxide is ionic. Would it conduct electricity as a solid? No. As a liquid, yes. So explain the electrical conductivities of sodium and sodium oxide in the solid and liquid states. Remember that any metal, like sodium, metallic structure, has free moving delocalized electrons, and that's why it can conduct electricity as a solid. Sodium oxide, or any ionic compound, as a solid, the ions are fixed as a solid in a 3-dimensional crystal lattice, but as a liquid, the ions are free to move. So ions are free to move only when liquid, but not when solid. Suggest how an electron density map of ammonium chloride would provide evidence for the presence of ions in the compound. Again, what do we mean by electron density maps? Electron density maps show contour lines or circular lines to indicate the shells, and if we have a covalent bond, then that outer shell or some of the shells would overlap. The contour lines would overlap. So if something is covalent, the contour lines overlap. If something is ionic, they do not overlap because the positive ions are away from the negative ions. If something has some covalent character, or what we call ion polarization, then that is how we draw the contour line. So what are we talking about here? Ammonium chloride. Ammonium chloride is ionic, and the electron density contour lines would go around the ions and do not overlap. Explain with reference to structure and bonding why electrical conductivity of graphite is 1 × 10⁵, while diamond is very, very small. Remember, what is the difference between diamond and graphite? We said in diamond, each carbon is covalently bonded to 4 other carbons, and that means there is no free moving electrons. While in graphite, graphite has each carbon covalently bonded to only 3 carbon atoms, and that means it has a 4th electron that is free to move, delocalized, and conducts electricity. While diamond, the carbon is covalently bonded to 4, so there is no free moving delocalized electrons. In the 1830s, the most explosive oxidizers called chlorates were discovered. One of these is potassium chlorate. So we're drawing dot and cross diagram for the chlorate ion, and use dots for chlorine, X's or crosses for the oxygen electrons, and an asterisk for the extra electron, because this is an ion with an extra negative charge. So again we said extra electrons are put on the oxygen. You put one of the oxygens. So here I chose the one on the right. Has an asterisk, so that means it needs only one pair of electrons to be shared with the chlorine. The others all need 2 electrons, so they're going to share 2 pairs of electrons with the chlorine. Now the chlorine has already used all its 7 electrons, so it doesn't have any extra electron away from bonding. State the bond angle and shape around the carbon atoms in diamond and fully justify your answer. Again, we said diamond, this is the shape of diamond. It's a tetrahedral structure, and you should know that tetrahedral structures have a bond angle of 109.5. Each carbon is surrounded with 4 bonding pairs of electrons, so this is for minimum repulsion between the 4 bonding pairs of electrons. Which diagram best represents the electron densities in lithium iodide? Again, we said if I have a positive ion that is small and a negative ion that is large, the small positive ion has high charge density, so it will attract the electron cloud that is around the ion, especially the negative ion. Especially if the negative ion is large, then the outermost shell is not really strongly attracted to the nucleus. So when we have a small positive ion with a large negative ion, there is some covalent character, and we said that means that the electron cloud around the iodine would be attracted to the positive ion. Of course, all of these are 1 positive ions. If we're comparing between 1 positive ion and a positive ion that has +2, then the +2 would have more polarizing ability. Which row of the table shows properties consistent with the type of bonding shown? Well, let's see. We're talking about what? Ionic. Ionic is soluble in water. Yes, ionic compounds are soluble in water. High melting temperature. Yes. Poor electrical conductivity as a solid. Yes. All the other choices are wrong. For example, D, when we say metallic, of course the metallic compound is insoluble in water. It has high melting temperature, but it would conduct electricity as a solid, so all of the others are wrong. So this is the end of this part, questions on chemical bonding. I hope that the topic is now a bit better understood, and thank you for listening.